Okay, so we'll look at some examples to apply the summation formulas, which should be straightforward. Let's go through this quickly. Okay, so we have 1 plus 3 plus 5 plus 7 up to 999. So this is essentially the summation of odd numbers starting from 1 to 999. Now you want to apply one of these formulas that we just saw. So if you notice here, it is from I equals 1 to n, so consecutive integers from 1 to n. That's how the formula is. So that means here we don't have in that format, but it could be transformed to that format. So if I add all even numbers that are missing here, we can use that formula. So that's what I'm doing here. I'm introducing a 2 that is missing, 4 that was missing, then 6, 8 up to 998. So it is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus up to 999. So this is a math trick that you commonly use. You have introduced or added some numbers, so you have to subtract those numbers. So minus, so you have to subtract all the even values that you introduced. So 2 plus 4 plus 6 plus up to 998. So those are the even integers that you introduced. So when you do that, you have added all the even integers from 2 to 998, and then you did minus all those that you introduced. So since you subtracted what you added, you are going to, the net result is going to be the same as 1 plus 3 plus 5 up to 999. So the value of the summation will not change by doing this. Now we have a ready-made format. Here is 1 up to 1 plus 2 plus 3 up to 999. So our n is 999. So that's why I kind of expand. So here it may not be very clear which of these three formulas to use, but you can always expand the summation, and I wrote one for this. So I equals, oh, I erased this, but no, which one can be used? This one, because this is I itself. So it is 1 plus 2 plus 3 plus 4 up to n, and that is n times n plus 1 over 2, and that's what I'm going to apply here. So n is 999, so 999 times 999 plus 1 over 2. Now to solve this, we can again try to use a similar summation. So here you see these are all even integers, so I can take the 2 outside and write as 1 plus 2 plus 3 plus 4 up to half of 998 is 499. And to solve this, I can use the same summation that we just used. This is 1 up to n is 499, so it is 499 times n plus 1, 500 divided by 2, and you simplify this math, you will get this answer. Okay, now you have another problem, 2 plus 4 plus 8 plus 16 up to 1024. Now you see here, we want to first decide which of the formulas we have to apply. So this looks like even integers, but it's not like all the even integers from 2 to 1024. This is only the exponents of 2, starting from 2 to 1024, 2 plus 4 plus 8, and then 16, then 32 plus 64, and so on. So that is like 2 raised to 1 plus 2 square plus 2 cube plus 2 to the power 4 up to 1024 is 2 raised to 10. Now we want to apply the last formula we saw here, but you remember I said in order to apply this formula, the index I star has to start from 0. But what we have is starting from 1, 2 raised to 1 up to 2 raised to 10. So we can use a similar trick that we used here. We can introduce a missing term and make it appear in a way that we can use a formula, and then subtract that missing term that we introduced. So we introduce here 2 raised to 0, that's the missing term. So we subtracted now minus the introduced term, just 2 raised to 0, which is 1. 2 raised to 0 is 1. So 2 raised to 0 plus 2 raised to 1, 2 square up, so up to 2 raised to 10 is in this format with a equals 2. And we saw that 2, it's in this format, n equals 10, so it's the same thing. So we saw that is 2047, right? So I equals 0 to 10, 2 raised to I, we got it as 2047, minus 1 is 2046. Okay, so any question on using these formulas with numbers like this?
No.
Okay. So let us now go through some general expressions involving summations. So I have sigma I equals 3 to n plus 1, 1. So we have a constant inside the summation. So if you look at these formulas, it falls in this category. Now, once you have a constant, you can apply what? The upper limit minus lower limit plus 1 formula. So upper limit is n plus 1 minus lower limit is 3 plus 1. Now if you simplify this, plus 1 minus 3 is going to be negative 1. So it's n minus 1. And n minus 1 can be written as state of n. You can discard the lower order term and just take the higher dominating term, which is n, state of n. So you notice here, sigma I equals 3 to n plus 1, 1 is state of n. Whereas sigma I equals 1 to n, 1 is also state of n. So you can see that the limits need not be exactly from I equals 1 to n. It could be somewhere around that. The lower limit is a constant. So as long as the lower limit is a constant and the upper limit is a function of n, function of n means is n, not n square or anything like that. If it's n square, also can apply the formula, but what goes inside here also be n square. Okay. So if the lower limit is a constant and upper limit is n, that's how I typically give something like this in an exam. Then, and what goes inside summation is a constant. So if all these things are applicable, the answer is state of n. So for example, if this is say I equals 5 to n minus 4, okay. So if you solve summation like that, let us work it out. So I equals say 5 to n minus 4, and let us see even have you have some constant 3. So if you want to work out this summation, this is going to be, first thing you have to do is, since you notice a constant inside the summation, you can take it outside and try to introduce 1 inside the summation. So I equals 5 to n minus 4, 1. And now what we can do is, since it's a 1 inside the summation, it's a constant, we can apply the upper limit minus lower limit formula. So it's going to be n minus 4 minus 5 plus 1, and that is 3 times n minus 4 minus 5 is negative 9 plus 1, that is negative 8. So it's n minus 8. So 3 times n minus 8 is like 3n minus 24, but you can again say discard the lower order terms and then discard the coefficient of the most dominating term, and we can simply say this is also theta of n. Okay, so this is what you should realize. So if it's a constant inside summation and this is from I equals, again a smaller constant value, to something involving n like this, that's going to be theta of n. Okay, like what I show here. So now we can work out this formula. Oh, okay, this is I in 1. Okay, so that's separate. So you see this is 1 here, but this is I. So this is a different formula that we have to use. So this is I equals 3 to n plus 1 I. So how to proceed? Now it looks like we have to use this formula that has I inside summation, but the loop index is not exactly from I equals 1 to n. We have I equals 3 to n plus 1. If it is from I equals 1 to n I, we can say that is n times n plus 1 over 2. But we cannot apply this formula right away here because the lower limit and upper limit are different. So let us see how to handle it. Now you can kind of what you call open up the summation, in the sense that by open up the summation I mean substitute the different values of I. So this is starting from I equals 3. So when I equals 3, it is 3. Then the next value of I is 4, so it is summation, so plus 4 plus I equals 3, 5, so plus 5 plus 6 up to n plus 1. So this is same as 3 plus 4 plus 4 up to n plus 1. That's what the summation means. So in order to apply this formula, it has to be 1 plus 2 plus 3 up to n. And what is missing here? We have 3 plus 4 plus 4 up to n plus 1. So we'll keep the n plus 1 as it is as one unit. We won't disturb it. And we will work with that as our kind of the last term. And what is missing here is 1 plus 2. So I'm adding 1 plus 2, then plus 3 plus up to n plus 1, minus added 1 plus 2, so I have to do minus 1 plus 2. Now this is like 1 plus 2 plus up to n plus 1. So anyone can say what's the answer for that? If you have 1 plus 2 up to n plus 1, we don't see such things in a math class. Let me increase the font size a little bit. So if we saw just earlier, if it is 1 plus 2 plus 3 up to n, the formula is n times n plus 1 over 2, right? So we can use the same formula here. Let me, if it is confusing, let me introduce capital N instead of lowercase n. So 1 plus 2 plus 3 up to this capital uppercase N is n times n plus 1 over 2. So now let n equals n plus 1. Is that clear? So we can say now 1 plus 2 plus 3 up to this is n, the uppercase n is n times n plus 1 over 2. So that means we can say this thing equals what? Instead of capital N uppercase N, we have n plus 1 times, instead of capital N substitute n plus 1 plus 1, there's another this plus 1, then the whole thing divided by 2. So that's why this is n plus 1 times n plus 2 divided by 2. So if it is up to n, it is n times n plus 1 over 2, right? So if it's 1 plus 2 plus 3 up to n, it is n times n plus 1 over 2. If it is 1 plus 2 up to n plus 1, that is instead of n, you are going to substitute n plus 1 like we just did here. And instead of n, n plus 1. So n plus 1 times n plus 1 plus 1, which is n plus 2. n plus 1 times n plus 2 over 2. Okay. Now if you have 1 plus 2 plus 3 up to n minus 1, what is the answer? Anyone? So again, try to visualize like this. If it's that will be easy to handle it. So we know this as our formula. put n, the uppercase n to be n minus 1 now. So we can say this thing is, instead of uppercase n minus 1 times uppercase n is n minus 1 plus 1 over 2. So it's going to be n minus 1 times n divided by 2. So that is n times n minus 1 divided by 2. Okay? Any question? Okay, good. Now, so we have basically here this term is what? This is what we were doing. So n plus 1 over times n plus 2 over 2, this whole thing minus the 2 plus 1 that we introduced here. So n plus 1 times n plus 2 over 2 minus this 1 plus 2, which is 3. Now you could spend time to really simplify the math here and get a final expression, but for this course purpose you don't really need to do such things. Once you get it into this format, we can right away use the theta notation. Now just for this first term, n plus 1 times n plus 2 over 2, that will be equal to theta of n square. We already did something similar to that some time back. You see, this n plus 1 is theta of n, and this is n plus 2 is also theta of n, and this is just a coefficient which can be discarded. So that is like theta of n times theta of n, which is theta of n square, minus 3. 3 is a constant. There's no n involved here. So this can be written as theta of 1. So it's theta of n square minus theta of 1. And that's like a lower order term, theta of 1. So we can discard it. We can even discard it right here. So theta of n square minus theta of n is simply theta of n square. So that's the most dominating term. Okay. So what you could realize here is, again, like in the earlier case, if there is an I inside and the limit starts from some constant I equals say 2 or 3, anything like that, or even 1 like you saw in the formula, and it goes up to say n plus 1 or n minus 4 or anything that has n in it like this, the summation is equal to theta of n squared. Okay, so the key thing is to have this I. So if it's I raised to 1, it is theta of n squared. Okay, if it's going to be I square like we are going to have, that's going to be theta of n cube, and I square is the dominating term here, so we'll work it out too, but we have to realize how the function, the term inside the summation and what goes inside the theta notation are related. Basically this is the general formula. Okay, so let us work this out. So we have I equals 0 to n minus 1 I times I plus 1. So if you first multiply this I inside, that's going to be I times I is I square plus I times 1 is I. So this whole thing is inside the summation. So sigma I equals 0 to n minus 1 I square, so we are splitting the summation, plus sigma I equals 0 to n minus 1 I. Now from our earlier experience with the examples and the formulas, we can simply state this is theta of n cube because we have an I square inside summation, and the limit goes from I equals a constant, in this case 0 to n minus 1. So we can say the first summation is going to be theta of n raised to 1 more than the exponent here, which is 2. So 1 more than 1 plus 2 is 3. So it's theta of n cube. And the second summation here, we have I inside the summation. and then I equals 0 to n minus 1. So again there's a constant n minus n involving something n. So this is I raised to 1. So that's going to be theta of n square. So we have finally theta of n cube plus theta of n square. The n square is not dominating compared to n cube. This is the most dominating term. So finally it is theta of n cube. Now here you don't really need to show these intermediate steps, but just you could still work out the math, because you can apply this formula I equals 1 to n I square. We have to of course do some adjustment in order to apply that formula. And this is that adjustment. Instead of basically n, you have to substitute n minus 1. Okay, and I think that will be sufficient to work it out. And so that is n times n plus 1 plus times 2n plus 1 divided by 6. And then again for this we have to, this is like n times n plus 1 over 2. So instead of n minus 1. Now for this case I said it has to start from I equal to 0, otherwise you have to do 1 plus and then do minus 1 like this. But for summations where I is in the base, not in the exponent, in order to apply the formula as it is, the I could start really from 0 and go up to n. In order to apply these two formulas, n times n plus 1 over 2, or these formulas, anything with I raised to 1 or I square or I cube, anything, you can apply these formulas as it is. Of course for this course you don't really need it, but for the math, if you're curious, I'm just telling you how to apply the formulas. So you do apply the formula, simplify, do all the math, you'll still get like this, where this term can be written as like what? Theta of n times theta of n times theta of n, which is theta of n cube. And this is theta of n times theta of n, which is theta of n square. So eventually it will come out to that. Okay. Any question? Alright, good. So let us do the last example and then we'll record this video. So alright, so I square plus 1 whole square, sigma equals 0 to n minus 1. So same thing. So here, before you open up the summation, you have to simply apply the formula, which is a plus b whole square format. And you shall see this in a school class. A plus b whole square is a square plus b square plus 2ab, or a square plus 2ab plus b square, whatever way you represent it. So this is I square whole square, which is I raised to 4, that is a square. So I square whole square is I raised to 4, plus 2ab, so 2 times I square times 1, which is 2I square, plus b square, which is 1 square, which is 1. So now this is all plus, so you can expand the summation. So this is I raised to 4 sigma I equals 0 to n minus 1 plus 2 times 2 is a coefficient, you can take it outside, sigma I equals 0 to n minus 1 I square plus some this is a 1, so I equals 0 to n minus 1 1. And we just saw if it is I raised to 4 and I going from a constant say 0 to something involving n in the upper limit, we can write it as theta of n raised to 1 more than 4, which is 5. So theta of n raised to 5, and this one is going to be theta of 1 more than 2, so n cube, plus theta of 1 more than I raised to 0, 0 more than 1 is n theta of n. So again we can discard the lower order terms and say this is simply theta of n raised to 5. Okay. Any question on this?